or a task, much like a different layer or a modular in architecture. So without organization, it's chaos. But with a clear structure, even complex system becomes easier to handle. In essence, good architecture saves times and the cost in the long run while improving code quality and the team collaboration. Going to the second slide, what is the comparison between the quick app and the scalable app? So we are in a software world. So everybody have heard about we need a app in a 2 days, we need a app in a 7 days. So everyone have heard about that jargons. So here we are looking at the difference between the building a quick apps and the scalable apps. Quick apps are built with the mindset of just getting it working. So there are several points. They focus on the speed of delivery, often skip architectural planning or a proper practice. As a result, they tend to accumulate technical debt, which means messy code, hidden bugs, and the future problems that are expensive to fix. On the other end, we have scalable apps. Scalable apps are built with a strong architectural foundation. They emphasize code quality, testing, and modular design. These apps are easier to maintain, extend, and scale as user or feature goes. The development may be slightly slower at the start, but it's pay off in the long run with fewer bugs and the easier updates. The image here is symbolic, a well architecture structure that balance from and a function, just like a scalable app. So as a developer, we need to ask to our management, like, do we want something fast and fragile or solid and the future ready? The third thing is about the layer of the clean architecture. So what are the layer in clean architecture? As we can see here, so there are four several layer. First one is a UI layer, second is a presentation layer, third one is a domain layer, and fourth is a data layer. So let's now look at the layers of clean architecture, a model that promotes the separation of concern, reusability, testability in the software system. So first of all, let's talk about the UI layer. This is where user interaction happen, like buttons, forms, skins, and etc. Whatever we can see from our eyes. It depends on the presentation layer, but never the other way around. Think of it as a view and the embassy or MVVM. Now going to the second layer, it is about the presentation layer. Handle state management, input validation, user flow, etc. Content controller, docs, view model, depending on your architecture style. It's talk to the domain layer, passing user action downs and rendering results ups. So presentation, talking with domain and send the results to the UI layer. Now going to the third layer, which is domain layer. This is responsible for the maintaining the repository use case and the core logic. And this layer is called as the heart of your application. It is independent of any external framework like UI, DB, or API. It's just an independent layer which is responsible to interact with data in the presentation. Now going towards the data layer. So data layer is responsible for the fetching and storing data from the API or storing data to the database or the shared preference. Implement the interface defined by the domain layer. So and if we have developed the clean architecture, then in domain we are defining our repository, which is only how the base class with the abstract methodologies, and the data and other in the data layer we are implementing that abstract class in a data layer with the concrete implementation. So this is about the data layer, and the data is always depend on the domain, but domain is unaware of it, what is inside the data. It's just having the abstract class. So the key principle here is the dependency rule. Code dependency always point inwards. This separation ensure your app is modular, testable, and easy to maintain or scale. The background image here subtly reflects this structure, layered and well organized, just like your CAD base should be. So be clearly defining this layer. We create a blueprint where change in one area like switching APIs or redesigning the UI won't ripple into the unrelated parts, reducing bugs and boosting team efficiency. Now going to the understanding the BLoC. So this is generally for the Flutter application where it is come under the presentation layer. So BLoC is a state management which is responsible for the emitting events and emitting the state. So if we see here, so BLoC stand for business logic component, a design pattern that separates presentation from the business logic in your Flutter apps. It's promote reusability and the testability by managing state through the stream and sync. So these are the concept of the BLoC. Like first of all, when we tap on the any button on the UI screen, So with the object of particular block, let's say if talking example of login screen, on type of the login button, we have to send the event to the particular block. It is listen the event, and based on the event, it will do that job and give us the state. Like if it is loading, it is giving us a loading state. If it is success, it is giving us a success state, and if it is error, it is giving us a error state. So this is the general definition of block. Now going to the role of the block in presentation layer. So the block acts as a central hub within the presentation layer, receiving user events and emitting state to the UI. As I told earlier, like it is responsible for events and emitting the state to the UI to render the respected things on the screen. This reactive approach enables a clean data flow and the efficient UI updates. So if we are not using block and directly do the same thing in a one file, then it may be harder to manage later once the new feature is come from the product. Going to the next thing, message passing in block. So like when the user click on the button, so now what happen when we have to show something to the user? So it is come from the state. So in block architecture, messaging passing in facilitate through the stream. So stream is a one way of communicating the things to block to the UI and UI to the block. So where events are added to the sinks and resulting states are emitted. This effectively manage the state and ensure that responsive user interface. So this is about block. Now going to the solid principle. So as we know, like we all know about the solid principle, but sometimes we are not using the exact principle in our code base with the like tight deadlines and everything. So now going to the first principle, what is the single responsibility principle? So if we talk in a general term, then it is like the apple tree is only responsible for the apple tree, not for the orange and everything. So the same way in the solid principle asserts that the class should have one reason to change. If we have a class of animal, then it should not contain the birds. So this is just a general example of that. In Flutter, this means components like block should focus solely on specific functionalities, such as handling login without handling concern like navigation and validation. So if we are building the login functionality, then the particular class should handle the login functionality only, not like our navigation and validation. So this is what it is explaining about. Now going to the open and close principle. So according to this principle, software entity should be open for the extension, but the close for the modification. So in Flutter, existing code should remain untouched while new functionality can be added through the new classes or method or the mixin or the abstract class, ensuring the stability. I'll explain all these stuffs in the code later on with a practical example. The third one is Lisco substitution principle. So everyone's know about it, but sometimes we are doing mistakes to understand this principle thoroughly. Like the Lisco substitution principle state that the subclass should be substitute for the parent class without expected behavior. So it is like if we have experience of writing test cases with the code which we are writing to build the application. So at that time, these principles come to the picture. So let's say if we are creating one abstract class. So in the real application, the abstract class is using the concrete implementation which is in the data layer. But what about the TDD test cases folder? So over there, we are mocking our abstract class with our own implementation, which is not always same as the production. So this is about that the Flutter adhering to the LSP allows developer to swap the out components seamlessly, maintaining functionality and the reducing bug. So this is generally for the like we are using for the test cases. So this is that principle follows. Now going to the interface segregation principle. So in our code, somewhere we have seen that there is one abstract class. It is having the three or four method. And whenever we are extending that abstract class, sometime even that particular module is not getting that methods, even though we are extending that method and returning to the exception. So this is not always fruitful. So the interface segregation principle advocates for creating a multiple small specific interface rather than a large general purpose one. In practice, this means that the Flutter service should not force implementation to rely on methods they do not use, promoting the cleaner code. So this is applicable for each and every language where we are doing the software development. The last one is about the dependency inversion principle. So the dependency inversion principle emphasizes that the high level module should not depend on the low level module. but the both should depend on the abstraction. So this is what about the dependency inversions. Like whenever we are creating the object, it is not directly creating the object. It instead it should go with the abstract class, and from the like wherever object creation is happening over there, we have to creating the concrete object creation. So this is what about the solid principle. Now going to the applied the solid principle in Flutter. So instead of this boring presentation, I'm going to the code and let me show you. So we have discussed all the solid principle laws. So first of all, I'll go with the solid single responsibility principle over here with the violation of it. So if we can see the code here, so this is written in Dart. Dart is a framework of Google, and we are using in a Flutter. So the same example can be relatable to the every language, each and every language. So here we have one class name is user manager, and inside that there is a two method. One is a add user and one is a send email. So as per the solid principle, it is violating the first law of solid single responsibility principle. Why? Because if you can see the code, the one class is doing the work of the two things, the sending emails and the add user. So how can we resolve this particular principle laws and fix it? So at the other end, I have created the same class, but with the compliant version of the single responsibility principle. So if you can look at it, so user manager is only responsible for the add user. And at the other end, we have created a separate class for the email services, which is only responsible for the send email. So each class should have the one responsibility. So this is what this particular principle learning us. Now going to the second principle is about the open and close principle. So here, if you can see, this is a one class discount calculator. Inside that, here is a one string. Depend on that, we are deciding that how much discount we have to give to the user. So if it is regular, we are giving the one. If it is a premium, we are giving to 0.2%. And if it is if there are no any from these two, then giving the 0% of discount. So now if you can see, this looks perfect, but it's not perfect. This is again violating the open close principle, because if you are sending something over here and if it is not handle here, then it will breaking the flow. So now if we see the compliant version of this principle, then it's look like this. So first of all, here we have created one abstract class which is only have one method of get discount. So if you can see, this is a get discount strategy. Now we have used this base class of the abstract class over here with the concrete class, which is about the regular discount and the premium discount. So now if you can, like how we can use this particular class. So you can see here. So here we again have a different class which will responsible for the giving you a discount exact amount of the discount. So here earlier, if you can see here, then it is a string. But if we see here, then it is a abstract class. So depending on your need, you can create play around with it and send the respected abstract class over here. So it will calculate the discount from here. So this is the way we can following this principle, like open for extension and close for the modification. So if we need to change anything in premium, you only need to change it here. But if we talk about these, then if you need to change something from the premium, then you are doing change here. So to the tester, they have to test everything for each and every function. So this is again the drawback for the QA to test the every functionality each and every time when you are changing something. Now going to the least code substitution principle. What is this? So here, if you can see, we have one class of bird. Here we have used the inheritance. So now if we see the real scenario, ostrich cannot fly, as we know. But if we are extending these birds over here, then we have to throw the exception over here, because ostrich never fly. So this is against the law of Velasco substitution. So how we can resolve this? Let's go to the compliant version of it. So here we have the bird class. The bird is having the two more classes, like the one is flying bird, and flying bird is having the bird extension, and it is having the one method of flying. So at the other hand, we are having the sparrow. So sparrow have ability to fly. So in that case, we are extending this particular class. And if it is ostrich, we don't need to extend anything close. This is bird, then we have extend bird. So if we need to pass something, then we are expecting the bird type of the parameter from the constructor. So this is how the subtype must be substitutes for the base class. So we can pass anything to the constructor. So here it is compliant lister substitution. Now going to the next principle about the interface segregation principle. So if you look at the code of the list square interface, and it's almost look similar. But here if you can see, so now we have a two method, one is work and one is it. So here inside the worker, we have two method. Now both the method we are using it over here. So let's consider like in our company, robot is doing our work. So whenever we are extending or implementing this class to the robot, so it is never applicable for robot. So in that case, we always writing the exception that robot don't it. So again, it's violating the interface segregation principle. So how to compliant this version? So let's go to that compliant version. If you can see here, we have a separate workable and the iterable abstract class over here, and both they have the separate method works and it. So human can do both the things, work, it, and so we can extend both the class over here and override the respected method. But what about robot? Robot can only work. So we have only extend the work. So this is how interface segregation work. And if we need anything else like human can go for a vacation, then we can write human class and vacation void take vacation. So we can directly use this class over here and we can just extend that methods over here. So this is how it's work. Now going to the next principle is about dependency inversion principle. So here if you can see the code looks like correct, but it's not correct. It's again violating the dependency inversion principle. So here we have one class which is responsible for the save your data to the MySQL. And that class we are directly creating the object over here and use it in the function like the save data. So now like what's the missing over here? So here missing is abstraction is missing over here. So now I'll show you the compliant version of this particular principle. So if you look at it, then it is having the one class of database and one method, one expect method of save, and it is accepting the string data. And now if you look at it, then the database is eliminated over here and the same method is override over here and do the same work which is doing in a violation version of it. But the benefit of this is to, if we want to test this particular abstract class and the functionality of it, if you implemented the abstraction, then it is easier to test testability of this class. Otherwise, whenever we are doing the testing of this class, it is always come to the real version of it. So it is a headache for us. So this is all about the all the principle. Now going to the next part, it is about the original example of it. So this is also I have explained via the code. So I'm skipping this out and now directly going to the code of the example. So this is the violated version of the example. This is the compliant version of example. So if you look at it, so here it is seems like the login manager is responsible for the everything like the validation and the API call and the token saved to the local storage and navigating to the home screen. So this class is violating all the principle like the handle validate like the first principle is a single responsibility. So it is saying that handle validation, networking, storage, and navigation, it is too much. Like it should have the separate class for each and every responsibility. Second one is about the open close. You cannot change login method without adding login method. So here we have everything in the one method. So if you need to change something, you are touching the login method. This is against this law. Now going to the LSP. So here no abstraction is used. So without abstraction, we have used everything. So we cannot test this particular function. Now going to the ISP like interface segregation, tightly coupled functionality, client get everything. So we do not have anything which will fill the encapsulation and the abstraction. And the last one is dependency inversion. That depend directly on the concrete implementation, not abstraction. So it is having directly method of login manager with the implementation. So now I'm showing the compliant version of it one by one. So first of all, look at the model. So here we have username and password. So like after calling the API, we will get the result as a username and token. So we have created a model. Then for the each service, we have created a separate class: auth, navigation, storage, and validator. If you look at the auth, then it is having the abstract implementation, like the abstract class of it, and at the other end, we have concrete class of the implementation. So it is like if we need to change anything in the login, we have to commit here and change it. Now going to the second, it is about the navigation. The same thing about the auth, like we have the abstract class and implementation of this method is over here, and the same way for storage, same way for validator. So it is using the uh, single responsibility principle, Lisco substitution principle, and the open and close principle. Both like three of the principle is following over here. Now this is about the service, and this is manager. So how manager is using over here. So if you look at the code, here we have auth service. So these all are the abstract method, not the concurrent implementation. So let's say if we want to testing as something else instead of this model, like in a validator, we have simple validator. So this is the actual implementation. So now we want to test something else, then you can create one more class over here and simply pass that parts in a constructor. So this is how it's look like the compliant version of the solid example. And this is the main file of it. Here we are using the all the creating the object of it and passing to the login manager. So that's all about this session. If anyone have any doubts regarding any line or any code, I'm happy to assist you. Sarala?
Yes, Hardik.
Yes, I'm done from my side. If candidate have any question about the my session, then they can ask me.
So participants, are there any questions for the session? I repeat, participants, are there any questions? Since there are no questions on behalf of everyone, thank you, Hardik, for taking the session today.
You're welcome, Sharla. Thank you, everyone.
For participants, now we will be having the feedback for the session. The feedback will be in the form of a poll. You all will be having 2 minutes to give the feedback for the session. Please note that it is mandatory for everyone who is joining the session to give the feedback. So I would request everyone to please give the feedback. The feedback poll is open.